Good morning. Today we are going to see how to find the correlation coefficient between x and y value for the given data. Start with the correlation coefficients. Okay. The formula to compute the correlation coefficient is formula to compute the correlation coefficient is between the variable x and y is r of x comma y is equal to covariance of xy divided by sigma x into sigma y. Here, the OV of xy is called covariance of xy. It is computed by sigma xy divided by n minus sigma x by n into sigma y by n, and it is called as covariance of x and y. And sigma x is computed by sigma x is equal to under root of sigma x square divided by n minus sigma x by n the whole square, which is called as standard deviation for x. Similarly, sigma y is equal to under root of sigma y square divided by n minus sigma y by n the whole square, which is called as standard deviation for y. Okay. Now we will see a property of correlation coefficient. That is, for the values of if x and y values are very large, that is the two-digit numbers, so it is hard to compute the value of the squares and sum it up. So we can do the shifting and scaling. That is u is equal to, if you shift the variable x as x minus a divided by h, and b is equal to y minus b divided by k. Here a, b are called shifting, and h, k are called scaling. So if you do the shifting and scaling, still the correlation coefficient value is unaltered. That is, the correlation coefficient of u comma v will be same as the correlation coefficient of xy. That is, the correlation coefficient xy will be same as r of u comma v, which is nothing but the covariance of u comma v divided by sigma u into sigma v. Next, the correlation coefficient properties. Okay, the correlation coefficient values. The correlation coefficient values lies between minus 1 to 1 plus 1. If r is equal to minus 1, sorry, minus 1, then it is called as perfect negative correlation if r is equal to r lies between minus 1 to 0, in between minus 1 to 0 is called as negative correlation if r is equal to 0, then it is called as uncorrelated. That is, there is no relation between the data x and y if r lies between 0 to 1, then it is called as positive correlation. And finally, if r value is equal to 1, then it is called as perfect positive correlation. Okay. Now I'll explain this concept by solving a problem. Find the correlation coefficient for the following data. Okay. The data are given as, here I can take it in the column wise. The data x is given as 65, 67, 66, 71, 67, 70, 63, 68, and 69. Like the corresponding value of y are 67, 68, again 68, 70, 64, 67, 72, and 70. You see here the value of x and y are two-digit number. So if you square the 65 square or 70 square or 68 square and then adding, it will be long tedious work. So first we will shift it, if possible we will scale it, and then we will find the correlation coefficient for UV, that will be same as the correlation coefficient for x and y. So for finding the value of A and B, you take the largest value plus smallest value divided by 2. That means range we can take it. So for A, you take the smallest value and largest value of x. So A, I can take it as 65 plus 71 divided by 2, which is 68. Similarly, to compute b, take the smallest and largest value of y, that is 64 plus 72 by 2, which is again 68. So we can take your a and b as 68. So now we will do the scaling to 68. Okay. So we'll do the scaling now. So you take your u as x minus a 68. So if I shift it, I will get minus 3 minus 1 minus 2 and then 371 minus 68 3 minus 1 2 0 and 1. Similarly, you do the scaling for b. In for y, we will get b is equal to y minus 68. So same thing. 67 minus 68 is minus 1. 0. 68 minus 68 0. 70 minus 68 is 2. 64 minus 78 will be minus 4. 67 minus 68 minus 1. 72 minus 68, which is 4. And 70 minus 68, which is 2. Next, I need the value of u into v, u square and v square value. First, you compute your uv values. So uv will be 3, 3 minus minus 3 into minus 1, 3, 0, 0, 6, 4, 2, 0 and 2. Next, the u square will be 9, 1, 4, 9, 1, 4, 0, 1 and then b square will be 1, 0, 0, 2, sorry, 2 square is 4, 16, 1, 16 and 4. Now we have to sum the values of u. The sum of u will be minus 1 and sum of v will be 2 and sum of uv will be 10 uv and then sum of u square will be 29 and sum of v square will be 42, right? So next we compute the correlation coefficient for u comma v. So we know that by the property that correlation coefficient of xy will be same as the correlation coefficient of uv, which is nothing but covariance of uv divided by sigma u into sigma v. Now we will compute one by one. So covariance of uv. So covariance of uv will be equal to sigma u into v divided by n minus sigma u by n into sigma v divided by n. The value sigma uv, here it is sigma uv will be 13 and the number of data will be 1 2 3 4 5 6 7 8. So n is equal to number of data, which is 8. So uv will be 13. So 13 divided by 8 minus, what about your sigma u? Sigma u will be minus 1 sum. So minus 1 by 8 into sigma v is 2, I think. Is it right? Yeah, 2. Sigma v is 2, so 2 divided by 8. So if you simplify this, I will get the covariance as 1, 6, 5, 6, 2. I can use the calculator. Next, we will compute the value for sigma u, standard deviation for u, that is sigma u is equal to under root of sigma u square by n minus sigma u by n the whole square. So it is equal to under the square root of, first we will find the sigma u square. Here the sigma u square is 29. So 29 divided by 8 minus sigma u, we already used it, which is nothing but minus 1. So minus 1 by 80 whole square. So if I use the calculator to compute this value, which is equal to 1.8998. Next, similarly, find your sigma v. The formula to compute sigma v will be is equal to under root of sigma v square divided by n minus sigma v by n the whole square. So which is equal to under root of the formula. The value of sigma v square is 20, sorry 42. So 42 divided by 8 minus sigma v already used in finding the u covariance, that is v is equal to sigma v is 42, sorry 2 divided by 8 the whole square, so which is equal to the value is 2.2776. Next, now we need to compute the value of R of u comma v, which is covariance of uv, that is 1.6525 divided by sigma u, that is 1.8998 into sigma v, 2.2776. So we will write it. So R of x comma y, which is same as R of u comma v, which is nothing but the covariance of xy, sorry uv. So that is 1.65625. So 1.65625 divided by sigma u 1.8998. So 1.8998 multiplied with 2 point sigma v 2.2776. So we will get the answer using the calculator as 0.382772. So it is a positive correlation. So we got that R of x comma y is equal to plus, the sign will represent the correlation type 0.382772. So which is positively correlated. Positive correlation or x and y are positively correlated. Positive correlation. So once again I will explain. Listen. So the question is find the correlation coefficient for the following data. The value of x and y I have written in the column wise. The first column will represent the value of x. The second column will represent the value of y. Here the value of x and y are in two-digit number, and squaring them and then adding will be little bit hard. So we have to shift it. If possible, we will do the scaling also. For shifting, we'll find the range. So for the range, you take the maximum and minimum value and divide it by 2. So A is equal to 65 plus 71 divided by 2. That is the average of largest value plus smallest value. Similarly for Y, take the largest value and smallest value divided by 2. In both the case, I got the A as 68 and B as 68. So we are going to shift U to X minus 68 and Y as Y minus 68. So if you shift and then find your UV and U square and V square. So and sum it up. So we got the summation of U as minus 1, summation of V as 2, summation of UV as 30, summation of V U square as 29, and summation of V square as 42. Then next we need to find the correlation coefficient for x and y. We know the property that the correlation coefficient for x and y will be same as the correlation coefficient for uv. The formula to compute the correlation coefficient for uv will be covariance of uv divided by sigma u into sigma v. So now we will compute the covariance for uv, which is summation uv by n minus summation u by n into summation v by n, that is 13 by 8 minus of minus 1 by 8 into 2 by 8, we will get the value as 1.65625. Similarly, we have to compute the value for sigma u, that is the standard deviation for u, which is the square root of sigma u square by n minus sigma u by n the whole square. So 29 by 8 minus of 1 by 8 the whole square, we got the value as 1.8998. Next we have to compute the value for sigma v, that is standard deviation for v, square root of sigma v square by n into sigma minus sigma v by n the whole square, that is 42 by 8 minus 2 by 8 the whole square. So if we use the calculator and simplify this, we will get the value as 2.2776. Next we will compute the correlation coefficient for UV, that is covariance of XY, that is 1.65625 divided by sigma u standard deviation of U as 1.8998 into standard deviation of V, that is 2.2776. So all are positive, so you will get the final answer is plus 0.382772. So that is your R of xy, so which is a positive correlation. Thank you.